Okay, then let's change this code. Okay, and this is the code we used for the estimating the house prices. Okay, and then let me save it. Let me save this as here. This just say 2. Okay. All right. Here, this is the data loading, right? And the priors, okay? B0 and B1. Previously, B0 and B1 were fixed. Now these are not fixed, okay? Now we have their own hyperparameters for B0 and B1, right? And we know that here B0 and B1 are both from inverse gamma distribution, a priori, right? Inverse gamma distribution, right? Alpha 0, 0, delta 0, 0, alpha 0, 1, delta 0, 1, right? Okay, then here, say alpha 0, 0 and delta 0, 0. And alpha 0, 1, delta 0, 1, right? So then, okay, let me do this. Okay, so then you see that here, see that this delta 0, 0 divided by alpha 0, 0 should be very small, right? It should be close to 0. And this one should be very large, right? So then say this, this is 100, or say, okay, 500, and say just 5, okay? Then what about this? This is just 5, and here 50, okay? Right. Because here alpha, sorry, delta 0, 0 divided by alpha 0, 0 should be close to 0. Okay, so we choose these hyperparameters so that this prime mean of B0 is close to 0, right? So this is prior for B0. This is prior for B1, right? What about small p? And p has the hyperparameters of alpha A0 and C0, okay? A0 and C0, okay? A0, C0, 0. Simply just 5 and 5. 5. So this is what? This is prior for P. Okay? So then the prior mean of P is just 1/2, right? 1/2. Of course, this is prior for sigma square, right? Okay. Right. Okay, then anything to change here? Okay, so we have the storage for beta, sigma square, gamma, and what? We need P. Storage for P. P is 0s n, 1. What about and B0, B0m, 0s n, 1. and b1 m equals zeros n comma 1, right? So these are storages. Right? And then also we need to initialize the parameters. Okay. Okay, what about p? P equals the 1/2, or you can initialize the p at the prior mean. Prior mean is what? A0 divided by A0 plus C0. What about the B0 and B1? And then of course B0 and B1 can be initialized their prior mean, right? Delta 0, 0. Delta 0, 0 divided by alpha 0, 0. Alpha 0, alpha 0, 0 or alpha 0, 0 minus 2, it doesn't matter either. So 1, 1. Okay, then okay, here. So currently we have 3 blocks, right? Beta, sigma square, and gamma. Now we are going to add another 3 blocks, B0, B1, and P. Okay, and then before doing that, let's run this code. Just make sure there is no error. All right, so it's running. I think, yeah, there's no error so far. Okay, it's good. All right, so then let's begin with P, because P is very simple. Okay, let me start B. P sampling. Okay, P sampling. Okay, so then in P sampling, what do you need? What do you need? Okay, what do you need? Here, you need what? Here, oh, sorry. Here, we need what? We need K0 and K1. The K0 and K1. Well, K0 is what? Number of 0 gamma k's, and this number of 1 gamma k's, right? Okay. Where are the gamma k's? Here. Gamma k is in here. Where is it? Where is it? Here, gamma. This is in gam, right? In gam. So then we need to define K0 and K1, right? I'll say K1 and K0, doesn't matter. And K0 must be what? K minus K1, right? What about this? This is sum. Okay. Sum gam equals 1. Okay. What is this? Gam double equals 1. It means what? This is statement. Okay. This is statement. This true or false. True is 1 and false is 0. And this is k by 1. Okay, capital K by 1. So then this statement is also k by 1, depending on it's a true or false. Okay. So then if the each gamma k equals 1, then the value of this double equality must be 1, otherwise 0. Okay. So then we have 12 outcomes, and then they must be either 0 or 1. So then this is capital K by 1, and this is summation. Okay, if this is false, then if gamma k's are 0, then this is false, and they are not included in these summations, right? So again, this by doing this summation, we can count the number of the important regressors or the number of one gamma case. Okay. So then now we sample P. P equals P should be generated from the beta distribution, right? And then how to generate from the beta distribution using MATLAB. Okay. Okay, here. Oh, God, it's so slow. Where is it? Or let me Google it. Okay, still okay. Here or just beta distribution, then okay, random number generator MATLAB. Okay, here. Right, beta R&D. Okay, beta R&D. Okay, beta R&D, and then its mean is what? Let's see. Number n can be vectors, matrix, array, or doesn't matter. Okay. Then okay. Yeah, I think yeah, beta R&D. Okay, beta R&D. Okay, so beta R&D. Okay, it should be A0 plus what? K1, C0 plus K0. Okay, then it's P sampling is done. Okay. Okay, let's try to run this. Okay, before then, this is counting the number of important regressors. Okay. Right. Then let's run this. Yes, it runs very well. Okay, and then of course we have to save PITR number 1 should be P. Okay. Did we ever define PM? Right. Yes, we did. Okay, let me run this again. Right. So then let's take a look at the posterior drawers of P. Right, and then plot and histogram. Right, looks good. Okay, looks good. Right. Okay. Right. Okay. I think, yeah. Okay. Now we are done with p sampling.